last thing that we need to talk about is Pascal's triangle. So Pascal's triangle was created by Pascal, and what he did was he realized that when you expand binomials, there's actually a pattern with their coefficients. So just for example, so if we look at the first or the 0 row, you have a plus b to the power of 0, where anything to the power of 0 is 1. In the first row, we're talking about taking the binomial to the power of 1. Well, anything to the power of 1 is just itself. Well, in front of the a, in front of the b, is a coefficient of 1, even though we don't actually write it. The second row, we're raising to the power of 2, so you have a plus b squared. Now, if I were to actually FOIL that out as a plus b times a plus b and simplify, I would get a squared plus 2ab plus b squared, where the coefficients are 1, 2, and 1. And anyway, you can keep going, and what if you expand it, you get this triangle. Well, then what Pascal did was he took those coefficients and created this triangle. And hopefully you see a pattern. So we have all ones down this side. We have all ones down this side. And in the center, the coefficients are just the sum of the digits on the diagonal. So the 2 here is really 1 plus 1. And the 3 is 1 plus 2. And this 3 is 2 plus 1. And so on. Then the next row, 4 is 1 plus 3 above it. 6 is 3 plus 3 above it. 4 is 3 plus 1. And so on. So if we wanted to create then the 6th row here, you'd have to start with a 1. 1 plus 5 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15, 5 and 1 is 6, and then you'd end it with a 5. So take a minute and see if you can figure out what the coefficients would be for the 7th row. For the 7th row, you should get 1, 7, 21, 35, 35, 21, 7, and 1. So that is the beauty of the coefficients. The other thing we need to look at are the variables. So let's look at the 4th row, for instance. So in the 4th row, we have an a. And then when you look at what happens to the variables when you expand it, starting on the left, you have a to the 4th, and then a cubed, then a squared, an a, and then a no a. And then if you look at your second term, which is the b, you actually start on the right this time, and you have b to the 4th. Moving in, you have b cubed, and then b squared, and then b, and then no b. So there's a pattern with the variables as well. So let's put those two patterns together, and let's actually expand. So if I want to find x minus 2 to the 5th, without Pascal's triangle, what you would have to do then would be x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2. And by golly, you could do it that way if you want to do it that way, but it's going to take you forever and a day, and nobody's got time for that. So thank you, Pascal, for figuring out this pattern. So what I want to do is, since I'm raising to the 5th power, I'm going to look at the 5th row. And I'm going to note the coefficients, 1, 5, 10, 10, 5, and 1. So to expand x minus 2 to the 5th, I'm going to use 1, 5, 10, 10, 5, and 1. So those are the coefficients. Now I'm going to look at my first term. And let's start on the left side. So that's going to be x to the 5th, then moving in, x to the 4th, x to the 3rd, x squared, x, and then no x. And now let's take a look at my second term here, which is negative 2. And let's start on the right side. So this will be negative 2 to the 5th times negative 2 to the 4th, and then a negative 2 to the 3rd, then a negative 2 squared, then a negative 2 to the 1st, and then no negative 2. And then after this, all we got to do is just simplify it. So my first term, I have 1 times x to the 5th, which is just x to the 5th. Then I have 5 times negative 2, which is negative 10. And I have a x to the 4th. Moving in, I have negative 2 squared, which would be a positive 4, and then multiply that times 10. So that's going to be 40 x cubed. Moving in, now I have negative 2 to the third, 2, 4, 8. So that's going to be a negative 8 times 10 will be negative 80 x squared. Moving in, now I have negative 2 to the fourth, which is going to be a positive 4. No, sorry, it's not 4. Negative 2 to the fourth, so 2, 4, 8, 16. Positive 16. 16 times 5 is 80. And then I have an x. And then moving out even further, I have negative 2 to the fifth power, 2, 4, 8, 16, 32. Because it's an odd number, it'll be negative. So my expansion is that. And that was a whole lot easier than foiling forever and a day the x minus 2. All right, so that's how you do that one. Now let's talk about doing part B, which is to the third power. So go back up to Pascal's triangle. Take a note of the third row. The coefficients are 1, 3, 3, and 1. So moving down here, went too far. So I need to do 1, 3, 3, and 1. All right, let's take a look at my first term here, which is 3y. Starting on the left, that'll be 3y to the third. Moving in, 3y squared, 3y, and then nothing. The last one here is a 1. So that's going to be 1 to the third, 1 squared, 1, and then nothing. Now, honestly, I didn't need to write all that because 1 to any power is just 1, but I'm just showing you how it works. So now I can go through and simplify. So 3y to the third, well, 3 to the third is 27. 27 times 1 is still 27. So I have 27. I still have to take y to the third. So 27y to the third. Moving in, I'll take 3 squared, which is 9. 9 times 3 is a positive 27. Then I still have to take y squared. Moving in, I'll take 1 squared, which is 1. 1 times 3 is 3. 3 times 3 is 9. So plus 9y. And then last but not least would be 1 to the third. So plus 1. So there it is, 3y plus 1 quantity cubed. So now I need you to try these two on your own. All right, for A, fully expanded, you should have got z to the fourth plus 12z to the third. Sorry, my pen's messing up there. That's a 12z to the third. Then plus 54z squared plus 108z plus 81. And then for B, you should have got 32t to the fifth minus 80t to the fourth plus 80t to the third minus 40t plus 10t, that should be a t, minus 1. All right, good job. So check your answers. If you don't get the same thing that I got, please go back and try to find your mistake. And if you can't find your mistake, please post in the comments what you got and what your question is on why you don't think you got the right answer. All right, there you go. Good job.